here we are at the end of this short journey. So far, we have explored strategies and techniques to leverage artificial intelligence tools in the learning process. And we have understood that these tools can help us achieve our learning goals more efficiently, effectively, and sometimes in a more engaging way. We also touched on how to go further by asking these tools to help us apply workflows. These workflows structure learning events in perhaps unexpected ways, drawing inspiration from frameworks by renowned educators like Kolb's cycle. We could go even further, for example, by asking the tools to plan daily and weekly study sessions following this cycle. In short, everything we have seen so far relies on constantly evolving tools that, at present, are versatile and effective, but have visible limitations. The research and development areas on which all the major players, Google, OpenAI, Anthropic, Meta, and so on, are focusing are truly fascinating. They allow us to envision new possibilities and learning methods that will make these processes increasingly dynamic and fluid, especially if the current gaps are bridged. So, let's try to understand which research areas interest us and what possible future scenarios might emerge. One of the main and ongoing research areas is related to red teaming, which is conducted by all the companies that design and release the leading models. Red teaming refers to the application of AI techniques and tools to simulate attacks, analyze vulnerabilities, or test systems, processes, or strategies, with the goal of identifying weaknesses or potential risks for users. Teaming for LLMs focuses particularly on important issues such as susceptibility to manipulative prompts or the generation of unethical content. This practice involves experts in ethical security and linguistics in various fields and significantly aids in preventing abuse, improving resilience, and mitigating risks related to bias and misinformation, making LLMs more reliable and secure. They are characterized by an increasingly robust ethical alignment. The big question remains about who defines the reference values, but at the very least we can remember that users, as both customers and citizens, have the ability to make their voices heard by expressing their preferences towards tools that they consider not only more effective, but also more respectful of the value system they identify with. Let's not explore further into the specifics of this field in great detail, but let's just say that all companies designing or releasing LLMs claim to conduct research and implement structured red teaming methods in this particular domain. At the same time, European public institutions are questioning the potential of AI systems and their possible harmful use in various domains. As we know, they are moving forward with regulations aimed at protecting user interests, such as the European AI Act. All of this should move towards a form of oversight aimed at ensuring the release of tools that are increasingly reliable and secure, at least within the European context. The other lines of research that are particularly interesting in this field are related to the development of functionalities aimed at amplifying the capabilities of systems, both in terms of immediacy of response and the use of different media languages and channels for receiving input and providing output. All of this is supported by the system's increasing ability to define context, which is used to interpret requests and provide appropriate responses, both in terms of content and personalization, based on the characteristics of the users. These lines of research, if properly integrated and developed, could open up interesting future scenarios in the context of continuous learning. Let's take a closer look at them. As mentioned earlier, as we have seen, LLMs are becoming increasingly fluid and adaptable in providing instant responses and feedback, which is crucial in today's fast-paced world. This capability of the models becomes even more relevant when effectively combined with the possibilities offered by the multimedia and multi-channel nature of such systems. Modern LLMs are multimedia, meaning they can handle input and output in various formats. Text, images, audio, and documents in different formats can be included in input messages, and the system can generate responses that can even be in video format or presented as interactive and engaging simulations. Claude, through the Artifacts feature, has the ability and potential to create simple simulators to be used for observing, for example, scientific, economic, and social phenomena. For example, it could generate a simulator to show how temperature variations affect the speed of a chemical reaction. However, be aware that these capabilities still have some limitations. Tools that interpret images provided as input for the systems often struggle to recognize textual elements, making it difficult to use them meaningfully. The handling of scientific writing in LaTeX, the language used in technical and scientific fields, still has significant limitations. Many models frequently tend to generate incorrect or non-optimized code, requiring substantial manual intervention to correct syntax or structures. Beyond multimedia capabilities, these advanced tools are now focusing on multi-channel functionality, meaning they can effectively use various channels to receive inputs and deliver outputs, such as the previously mentioned audio channel. The continuous transition from audio format dialogue to textual and written dialogue could indeed open up truly fascinating, remarkable, and extraordinary educational possibilities. Not only that, OpenAI has already developed new features where the model can access the camera of our mobile device to observe the surrounding space, describe it, interpret it, and gather data not only from our verbal requests, but also from the environment and the people around us. All these features, such as these, could make artificial intelligence tools particularly versatile in the future, in supporting the understanding of complex content. Through the generation of visual and interactive resources that enable continuous dialogue via audio or text. Imagine, for example, an artificial intelligence tool that uses visual input to analyze a scientific experiment while you perform it, suggesting improvements, recalling formulas and processes, or explaining phenomena in real time. The access of tools to the surrounding environment could lead to an even more contextual and personalized level of interaction. Another key direction of development is precisely linked to the personalization of responses, which stems from the ability of LLMs to deeply understand the context. This includes the semantic analysis of a text to define the most effective context within which to sift through information in order to generate a high-quality response, as well as the ability to recognize the user's intentions based on characteristics stored through a complex profiling process. Advancements in this area could enable LLMs to interpret ambiguous or incomplete requests, providing relevant responses. And, supported by specific methods, they can connect complex concepts with concrete and relevant examples for the user. Here too, the limitations are somewhat evident. On one hand, contextual analysis and response quality are still unbalanced depending on the discipline. For example, problems related to disciplines such as physics and mathematics, which require complex interpretation and logical processing, are still often solved by many tools in a naive manner, or with errors. On the other hand, personalized response profiling methods do not always improve the outcome. There is GPT, for example, LAIS, which is capable of updating its memory based on user characteristics. However, the risk, and sometimes the observed outcome, is that responses remain anchored exclusively to the stored context, without offering innovative insights or exploring possibilities beyond what is already known. The attempt is therefore very interesting, but at the current stage, it can still be improved. Sometimes there is a feeling that this functionality might prevent us from going further. Therefore, the prospects are vast and open up interesting, constantly evolving scenarios, and all of them are yet to be explored. Reflecting on the presented methodologies and applying them in your personal context is the first step to consolidating what you have learned. Try experimenting and observe how these tools can transform your experience. Identify new strategies that apply to your specific context and recognize the limitations with a critical eye. However, don't forget that artificial intelligence is just a tool, one of many resources available within your broader learning ecosystem. The real strength lies in your ability to learn, creating useful and meaningful connections. Artificial intelligence tools are new allies in this process, but you are the one guiding your journey. Your learning potential is vast, and now you have new resources at your disposal to explore it to the fullest.